Welcome to Sleepy Secrets. Tonight, we're diving into 100 mysterious secrets about the moon. From its violent origins and hidden dark side, to the strange ways it may still shape Earth, human history, and our future in space. Along the way, we'll explore forgotten lunar mysteries, astronaut stories, ancient legends, and secrets buried beneath the moon's silent surface. Before we begin, leave a comment telling me what city you're watching from tonight, and let's slowly drift into the mysteries of the moon together. More than 4 billion years ago, before forests, oceans, or even continents existed, the young Earth may have looked less like a planet and more like a wound glowing in the darkness of space. Rivers of magma stretched across enormous distances beneath skies filled with ash, vaporized metal, and constant impacts from asteroids left over from the formation of the solar system. Nothing about this world was stable. Mountains rose and vanished beneath molten floods. Entire regions may have been remade in a matter of hours. The Earth we know today had not truly been born yet, and somewhere within that chaos, another world was moving silently through space. Scientists call it Theia, a lost protoplanet that may have once orbited the Sun alongside the early Earth. Nobody has ever seen it, and no direct trace of it has ever been found floating through the solar system. Its existence survives mostly through mathematical models, lunar chemistry, and one haunting possibility. The moon may be all that remains of it. Many planetary scientists believe Theia was roughly the size of Mars, large enough to become a world in its own right. For millions of years, it may have traveled through nearby orbital paths while gravity slowly pulled both planets toward disaster. At some point, perhaps after countless near encounters, the two worlds finally collided. The scale of that impact is almost impossible to visualize. It was not an explosion in the ordinary sense. Entire planets were involved. Modern civilization has never witnessed anything remotely comparable. When Theia struck Earth, the energy released may have exceeded billions of nuclear weapons detonating simultaneously. Parts of both worlds likely vaporized instantly. Oceans could not exist yet because the surface itself may have temporarily become an ocean of molten rock. For a brief period, Earth may have glowed brighter than some stars visible in today's night sky. And strangely, one of the greatest mysteries is that the collision may not have been a direct hit at all. Some simulations suggest that if Theia had struck Earth head-on, both worlds might have merged differently, and no moon would have formed. Other models show that if the angle had been only slightly shallower, enormous amounts of debris could have escaped into deep space forever. Somehow, in the middle of complete planetary violence, the conditions appear to have aligned almost perfectly. The impact scattered molten material outward into orbit around Earth, forming a gigantic ring of vaporized rock and debris glowing around the planet like a second sun. Over time, gravity slowly pulled that debris together. The moon began to form. But even today, scientists still argue about exactly how that process happened. Some models suggest the moon formed relatively quickly, perhaps within only a few years or decades after the collision. Others propose it may have taken much longer, as fragments repeatedly crashed together in orbit. What makes the mystery difficult is that the evidence points in multiple directions at once. The Moon resembles Earth too closely in some ways, yet remains strangely different in others. That puzzle became much more serious after the Apollo missions. When astronauts returned from the Moon carrying lunar rocks, scientists expected to find evidence showing the Moon formed elsewhere in the solar system. Instead, many of the samples contained oxygen isotope signatures astonishingly similar to Earth's rocks. The match was so close that it transformed the giant impact theory from an interesting possibility into the dominant scientific explanation. In simple terms, the Moon appeared genetically related to Earth. Some researchers began describing the Moon as a surviving fragment of the early Earth itself, a fossil from a time before the modern planet existed. And yet, the isotope mystery also created a new problem. If Theia truly collided with Earth, scientists expected the Moon to contain clearer chemical differences from the destroyed planet. Instead, the compositions appeared unusually blended together. That forced researchers to rethink the collision entirely. Some newer theories suggest the impact was so violent that both planets partially vaporized and mixed into a single rotating cloud before separating again. Others propose Earth may have spun incredibly fast after the collision, changing the physics of how the debris formed the Moon. The deeper scientists investigate the Moon's origins, the stranger the story becomes. One particularly fascinating possibility suggests Earth may once have had two moons instead of one. According to a hypothesis explored by some planetary researchers, the giant impact may have created multiple lunar bodies orbiting Earth at the same time. Over millions of years, gravitational interactions could have caused one smaller moon to collide with the larger one. Some scientists think this ancient merger might help explain why the Moon's near side and far side look dramatically different today. The side facing Earth contains vast, dark volcanic plains known as Maria, created by ancient lava flows billions of years ago. The far side, however, appears rougher, thicker, and heavily cratered. For centuries, humans never even knew the far side existed, because the Moon is tidally locked, always showing the same face toward Earth. That fact alone is quietly eerie. Every human being who ever lived before the space age saw only one hemisphere of the Moon. The hidden side remained invisible for all of human history until spacecraft finally photographed it in the 20th century. And when those images arrived, the far side looked nothing like many scientists expected. The Moon itself was already becoming more mysterious instead of less. Another strange detail is how enormous the Moon appears relative to Earth. Most moons in the solar system are tiny compared to the planets they orbit. Earth's moon is unusually massive by comparison. Some astronomers have pointed out that the Earth-Moon system behaves almost more like a binary planet system than a traditional planet and satellite arrangement. That size may have changed the history of Earth permanently. Without the Moon's gravitational pull, Earth's axial tilt could have shifted chaotically over millions of years. Some climate simulations suggest the planet might have experienced violent swings in weather and temperature difficult for complex ecosystems to survive. The moon acts almost like a stabilizing anchor, gently controlling Earth's orientation as both worlds travel around the sun. In a strange sense, human civilization may owe its existence to an ancient planetary collision. And billions of years ago, the moon itself looked completely different. Shortly after forming, scientists believe the young moon may have been covered by a global magma ocean. Imagine looking upward from the early Earth and seeing not the pale gray moon of today, but an enormous, glowing sphere, streaked with molten rivers and volcanic eruptions. Because the moon orbited much closer to Earth back then, it would have appeared vastly larger in the sky, perhaps several times wider than the modern moon. The tides during that era may have been colossal. Some researchers think ancient coastlines could have experienced tidal surges far stronger than modern ones. Earth also rotated much faster. A full day may have lasted only a few hours compared to today's 24-hour cycle. The relationship between Earth and Moon was more intense, more unstable, and more violent than the calm night skies humans know now. And even after billions of years, the Moon still preserves scars from that ancient age. Unlike Earth, the Moon has almost no atmosphere, weather, or plate tectonics. Nothing erases its surface efficiently. Craters remain visible for unimaginable stretches of time. Some scars on the Moon formed before the oldest surviving rocks on Earth even existed. In many ways, the lunar surface acts like a frozen archive of the early solar system. Earth erased much of its own violent history. The Moon kept the evidence. That evidence may even extend beneath Earth itself. In recent years, scientists studying enormous dense structures buried deep near Earth's core have explored a controversial possibility. Could these regions contain remnants of Theia? The idea remains speculative, but some researchers believe parts of the destroyed protoplanet may still exist trapped inside Earth's mantle after billions of years. If true, fragments of the world that created the Moon may still lie beneath our feet right now. A dead planet hidden inside another planet. Perhaps the strangest part of all this is how delicately balanced the outcome appears in hindsight. Across the early solar system, countless worlds collided and disappeared forever. Some shattered apart. Others spiraled into the sun. Entire planetary systems may have failed before stable worlds could form. Yet one catastrophic collision near the young Earth produced something extraordinary. A moon large enough to stabilize climates, shape tides, influence biological rhythms, guide ancient navigation, inspire myths, and illuminate human history for thousands of generations. And even now, the story is still changing. Laser reflectors left behind by Apollo astronauts revealed that the Moon slowly drifts away from Earth every single year, moving outward by roughly 3.8 centimeters annually. It is a tiny distance on human timescales, but over hundreds of millions of years, the separation becomes enormous. Long ago, the Moon dominated Earth's skies. Far in the future, it will appear smaller than it does tonight. One day, total solar eclipses may disappear entirely because the Moon will no longer perfectly cover the Sun from Earth's perspective. The night sky itself is temporary. And perhaps that is what makes the moon so fascinating. It feels eternal, yet almost everything about it was shaped by instability, destruction, coincidence, and time. The calm silver light humans see today may be the surviving aftermath of one of the most violent events in Earth's history. A reminder that sometimes entire worlds must break apart before something extraordinary can exist. Tonight, it may feel as though the moon is simply hanging there above the world in silence, calm, motionless, almost decorative. But for billions of years, that pale object in the sky has been quietly pulling on Earth, with enough force to move entire oceans, slow the rotation of a planet, shape animal behavior, and possibly help life survive long enough for humans to eventually stare back at it. In ways most people never notice, the moon does not merely orbit Earth, it controls it. Every moment you stand beside the ocean, the coastline beneath your feet is rising and falling because of gravity stretching the planet itself. The tides are not just water moving randomly toward shore. Earth is constantly being pulled into a slightly distorted shape by the moon's gravitational force. Oceans bulge outward. Even parts of the solid crust shift slightly. The entire planet responds to the moon continuously, whether humans notice it or not. And billions of years ago, that influence may have been far stronger than it is today. The early moon orbited much closer to Earth than it does now. In the ancient sky, it would have appeared enormous, perhaps several times wider than the modern moon. Nights may have been dramatically brighter. Tides would have surged across coastlines with overwhelming force. Some scientists believe certain early shorelines may have flooded and retreated over huge distances repeatedly as gravitational forces reshaped the young oceans. And strangely, those violent tides may have helped life begin. One scientific idea suggests that tidal pools created by the moon's gravity could have concentrated organic molecules along ancient coastlines billions of years ago. As water repeatedly flooded and evaporated, chemicals essential for life may have become increasingly concentrated. Certain researchers believe these cycles could have encouraged complex molecular reactions long before the first true cells existed. The moon may not have created life directly, but it may have helped prepare the stage. That possibility becomes even more fascinating when you realize Earth is unusual. Many planets in the solar system either have tiny moons or none at all. Yet Earth possesses a massive companion capable of exerting significant gravitational influence over the entire planet. Some astronomers have argued that without such a large moon, Earth's history may have unfolded very differently. Because the moon does something else almost invisible. It stabilizes the planet itself. Earth does not spin perfectly upright. The planet tilts at an angle of roughly 23.5 degrees as it travels around the sun, creating seasons. But that tilt is not completely fixed. Over long periods of time, gravitational forces from other planets slowly influence Earth's orientation. The moon acts almost like a stabilizing weight, helping prevent the planet from wobbling too violently. Without the moon, some climate models suggest Earth's tilt could have shifted dramatically across millions of years. Instead of relatively stable seasons, the world may have experienced extreme swings, difficult for complex ecosystems to adapt to. Certain regions might have transformed unpredictably between frozen wastelands and scorching environments over geological timescales. Some researchers believe advanced life may have struggled to evolve under such unstable conditions. In a strange way, the moon may be one of the reasons Earth remained calm enough for forests, animals, and eventually civilizations to survive. And yet the relationship between Earth and Moon is not peaceful. The Moon constantly steals energy from Earth. Every day, tidal friction slightly slows the planet's rotation. It happens incredibly gradually, almost invisibly across human lifetimes. But over billions of years, the effect becomes enormous. Long ago, Earth spun much faster than it does today. Some scientists estimate that early days on Earth may have lasted only 5 or 6 hours. Imagine a sunrise and sunset racing across the sky 4 times faster than modern days. Back then, storms may have behaved differently. Winds may have moved differently. Biological rhythms would have unfolded inside a much shorter planetary cycle. But as the Moon continued pulling on Earth's oceans, rotational energy slowly transferred outward. Earth's spin began to slow. At the same time, the Moon slowly drifted farther away. Even now, laser experiments left behind during the Apollo missions reveal that the Moon continues moving away from Earth by roughly 3.8 centimeters every year. It is an almost invisible change on human timescales, but over hundreds of millions of years, the effect becomes dramatic. Ancient eclipses would not have looked the same as modern ones. The Moon once dominated Earth's skies far more aggressively than it does today. And one day, far in the future, total solar eclipses may disappear completely because the Moon will no longer appear large enough to fully cover the Sun. The night sky humans take for granted is temporary. The Moon's influence extends beyond oceans and planetary motion. Across Earth, countless species behave differently depending on lunar cycles. Coral reefs release eggs and sperm into the water according to moonlight timing. Certain fish hunt more actively during full moons. Some predators rely on brighter nights for visibility, while prey species retreat deeper into cover. Even today, biologists continue discovering animals whose reproductive cycles remain synchronized with phases of the Moon. That connection stretches back astonishingly far in evolutionary history. Before artificial lights existed, moonlight shaped the rhythm of darkness itself. Ancient nights were not equally dark. A full moon could transform landscapes completely, illuminating coastlines, forests, and deserts with enough light for hunting, migration, or travel. During a new moon, however, the world became profoundly black. Many early humans likely organized parts of their lives around that changing brightness. Some anthropologists believe moon phases may even have influenced sleeping behavior long before recorded history. Research into whether lunar cycles still affect modern human sleep remains debated and inconsistent, but certain studies have suggested subtle changes in sleep duration or sleep quality during full moons. Other researchers remain skeptical, arguing the evidence is too weak or inconsistent to draw strong conclusions. Still, it is difficult to ignore how deeply the Moon became woven into human behavior across cultures separated by oceans and continents. Long before clocks existed, humans watched the moon to measure time. The word month itself comes from lunar cycles. Ancient civilizations tracked the changing phases carefully because the moon provided one of the most predictable visible patterns in the sky. Farmers used lunar calendars. Sailors navigated partly through moonlight and tides. Priests and rulers linked celestial events to rituals, harvests, and political power. The moon became humanity's oldest natural clock, and occasionally, it terrified people. A lunar eclipse can still feel eerie even today. The moon slowly darkens while turning deep red beneath Earth's shadow. Ancient civilizations often interpreted these events as warnings, omens, or signs of divine anger. In some cultures, people believed creatures were devouring the moon itself. Others thought eclipses predicted war, famine, or disaster. The emotional power of the moon over human imagination may have emerged partly because it changes so visibly. Unlike most celestial objects, the moon evolves night after night before human eyes. It grows, disappears, returns, darkens, reddens, and shifts position continuously. Ancient people did not need telescopes to notice that the moon felt alive in some strange way. And in a sense, Earth itself responds to the moon, almost like a living system. Scientists studying Earth's oceans have discovered that tides influence mixing patterns that help distribute nutrients through marine ecosystems. Certain coastal habitats exist largely because tidal systems create constantly changing environmental conditions. Some researchers have even argued that tidal rhythms may have influenced the movement of early animals transitioning between sea and land. The moon's gravitational influence may quietly echo through the history of evolution itself. And yet, despite all this control, the relationship remains fragile. If the moon had formed slightly farther away, tidal forces would have been weaker. If it had been smaller, Earth's tilt may have destabilized more easily. If the moon had never existed at all, the modern world could look unimaginably different. There might still be oceans. There might still be life. But the path that eventually produced humans may never have unfolded in quite the same way. That realization changes the emotional scale of the moon entirely. It stops feeling like an object hanging above Earth and starts feeling more like a hidden force embedded inside the planet's history from the beginning. Human civilization developed beneath its light. Entire ecosystems adapted to its cycles. Ancient coastlines rose and fell because of its gravity. Even Earth's rotation continues changing because of its presence. The moon is not separate from Earth's story. It is part of the machinery that shaped the world humans inherited. And perhaps the strangest part is that most people rarely think about it at all. Tonight, while cities glow beneath artificial lights and oceans continue shifting beneath invisible gravitational forces, the moon is still quietly pulling on the entire planet, exactly as it has for billions of years. It slows Earth by tiny fractions of a second. It lifts the seas. It influences migrations, spawning cycles, coastlines, and darkness itself, all from nearly 250,000 miles away. A silent object controlling a world without ever touching it. Long before telescopes, rockets, or modern astronomy, human beings were already staring at the moon with a mixture of fascination and fear. It appeared too alive to ignore. Unlike the distant stars that remained fixed night after night, the moon constantly changed. It grew larger, then smaller. Sometimes it vanished entirely. Occasionally, it turned red. At times, it rose enormous above the horizon, glowing through fog and smoke like something watching from beyond the earth itself. For ancient people living beneath truly dark skies, the moon did not feel like an object floating in space. It felt present. Thousands of years ago, before artificial lights drowned the heavens, moonlight shaped entire nights. A full moon could illuminate rivers, deserts, coastlines, and forests with enough brightness to travel by. Shadows stretched across the ground. Animals changed their behavior. Hunters stayed awake longer. Predators moved differently. Human beings evolved beneath these shifting cycles of darkness and silver light for so long that it is difficult to separate early civilization from the moon itself. And because nobody understood what the moon truly was, nearly every ancient culture tried to explain it in its own way. In ancient Egypt, the moon became deeply connected with wisdom, time, and divine order. One lunar deity associated with the moon was Thoth, a god linked to knowledge, writing, mathematics, and measurement. The connection was not random. The moon moved with remarkable predictability compared to the chaos of human life. Floods came unexpectedly. Crops failed. Kings died. But the moon always returned. That reliability made it feel powerful. Many ancient civilizations believed celestial order reflected a hidden structure behind reality itself. Watching the moon became more than astronomy. It became a way of understanding existence. Far across the world, ancient Chinese mythology imagined the moon very differently. One of the most enduring stories tells of Chang'e, a woman said to have ascended to the moon after drinking an immortal elixir. In some versions of the legend, she becomes isolated there forever, separated from the human world beneath her. Even today, traces of that mythology survive in modern Chinese lunar festivals and space exploration programs named after her. What makes stories like these fascinating is not whether they are literally true. It is how often human beings imagined the moon as inhabited, conscious, or emotionally alive. Again and again, civilizations treated the moon less like a rock and more like a presence. The Greeks imagined Selene guiding the moon across the heavens in a silver chariot. In Japanese mythology, Tsukuyomi emerged as a mysterious moon god associated with night and order. The Maya tracked lunar cycles with astonishing precision, centuries before modern instruments existed. Some ancient cultures viewed eclipses as celestial battles. Others believed the moon itself was being devoured. And, strangely, many of these civilizations developed similar emotional reactions despite being separated by oceans and continents. Fear, wonder, reverence. It is possible part of that emotional connection came from how unpredictable the moon sometimes appeared. Lunar eclipses, for example, could transform the bright moon into a deep red sphere hanging silently above entire cities. Today, people understand the phenomenon scientifically. Earth's atmosphere bends sunlight into the planet's shadow, filtering out blue wavelengths while allowing red light to reach the moon. But ancient people had no such explanation. Imagine standing beneath a dark sky thousands of years ago while the moon slowly turned blood red overhead. It would have felt impossible to ignore. Some civilizations interpreted eclipses as warnings of war or disaster. Ancient Mesopotamian rulers occasionally hid during eclipses because they feared celestial omens predicting their deaths. In parts of Asia, myths described dragons or giant creatures consuming the moon itself. Across different societies, humans banged drums, shouted, or lit fires in attempts to scare away whatever was attacking the sky. The emotional intensity surrounding eclipses reveals something important about early humanity. The moon was not background scenery. It was woven directly into how people understood danger, time, power, and survival. That influence extended far beyond mythology. Ancient people also relied on the moon in deeply practical ways. Before mechanical clocks existed, lunar cycles helped organize human activity. The moon became one of humanity's earliest reliable calendars. A full lunar cycle lasts roughly 29.5 days, close enough to shape the concept of months still used today. Some of the oldest known calendars on Earth appear linked to lunar observations. Hunter-gatherers may have tracked moon phases tens of thousands of years ago using carved marks on bone or stone. Archaeologists continue debating exactly how sophisticated those early observations were, but there is little doubt humans noticed lunar patterns extremely early in history. The moon offered something rare in a dangerous world: predictability. You could lose crops, you could lose entire cities, but the moon kept returning. That predictability became especially important for ancient sailors. Long before GPS or magnetic navigation systems, moonlight helped illuminate coastlines and open water during nighttime travel. Tides shaped harbors and fishing cycles. Some ancient mariners timed voyages according to lunar phases because stronger tides could dramatically affect coastal movement. In a strange sense, the moon quietly guided exploration long before humans understood oceans scientifically. And the deeper researchers study ancient monuments, the more evidence they find that lunar cycles may have influenced architecture itself. Certain prehistoric structures appear aligned with rare lunar events. One famous example is the ancient site of Callanish in Scotland, where standing stones may have been arranged partly around long lunar cycles occurring over nearly 2 decades. Similar theories surround other ancient monuments across Europe and the Americas. Not all archaeologists agree on every interpretation, and some alignments may be coincidental. But enough patterns exist to suggest many ancient societies watched the moon far more carefully than modern people often realize. The sky was once treated almost like a sacred text, and few objects dominated that text more than the moon. Over time, the moon also became associated with human behavior itself. The word lunatic ultimately traces back to ancient beliefs connecting madness with lunar phases. Even Aristotle and Pliny the Elder discussed ideas linking the moon to unusual behavior. During the Middle Ages and well into later centuries, many people believed full moons could trigger violence, insanity, sleep disturbances, or supernatural transformations. The werewolf legend may be one of the most famous examples. Stories of humans transforming beneath moonlight appeared across parts of Europe for centuries. Some historians believe these myths may have evolved partly from ancient fears surrounding nighttime predators, psychological illness, or unexplained violence occurring under brighter lunar conditions. Others think the legends reflected something deeper: the uncomfortable feeling that moonlight changed the emotional atmosphere of the world itself. Even now, modern studies exploring whether lunar phases affect human behavior remain controversial. Some researchers report weak correlations involving sleep or mood, while many others find no convincing evidence at all. But the persistence of lunar myths across history suggests the emotional influence of the moon was undeniably real, even if the physical mechanisms remain uncertain. Human beings projected meaning onto the moon constantly, and perhaps that was inevitable. Unlike the distant stars, the moon feels close. It visibly changes shape. It dominates eclipses. It controls tides. It lights the night strongly enough to transform landscapes. In ancient darkness, the moon would have appeared almost impossibly powerful. There is also another reason ancient cultures may have become obsessed with it. The moon helped humans think beyond Earth. Early astronomy likely began partly because people watched the moon so carefully. Once civilizations noticed celestial patterns, they started tracking planets, seasons, eclipses, and eventually, the larger structure of the heavens themselves. In that sense, the moon may have acted as humanity's first doorway into cosmic thinking, a bright object that encouraged humans to look upward and ask questions. What is it? Why does it change? Why does it disappear? Why does it return? Those questions eventually led toward mathematics, calendars, navigation, astronomy, and science itself. But even after modern knowledge revealed the moon's true nature, some of its emotional mystery survived. Astronauts who traveled there during the Apollo missions often described the moon as strangely unsettling, despite understanding its geology scientifically. The silence felt unnatural. The landscape looked ancient beyond comprehension. Earth hung in the black sky above them like a distant, glowing memory. Perhaps that reaction connects modern humans with ancient ones more closely than people realize, because despite all our technology, the moon still does something unusual to the human imagination. It slows conversations. It changes the feeling of the night. It makes people stop and look upward. And for thousands of years, civilizations rose and disappeared beneath its light, while trying to understand what it truly meant. A silent object that ancient humans turned into gods, omens, calendars, monsters, spirits, prophecies, and legends. Not because they were foolish, but because the moon has always felt like more than just a world floating in space. From Earth, the moon often looks smooth, calm, almost simple. A pale silver sphere hanging silently above clouds and oceans. But the closer humans looked, the stranger it became. What once appeared peaceful through the naked eye slowly transformed into a landscape filled with scars, shattered mountains, frozen explosions, endless dust plains, and mysteries scientists still argue about today. The moon is not quiet because nothing ever happened there. It is quiet because almost nothing changes anymore. For billions of years, the lunar surface has remained exposed directly to space without weather, rain, rivers, or wind to erase its past. Every impact, every violent collision, every crater remained preserved like fingerprints trapped in stone. In many ways, the moon is less like a world and more like a fossil of the early solar system. And some of its oldest scars are almost impossible to comprehend. Certain lunar craters formed so long ago that they are older than nearly every surviving surface on Earth. While tectonic activity, oceans, and erosion constantly reshaped our planet, the moon simply kept its memories. Entire eras of cosmic violence remain frozen there in silence. One of the first strange discoveries humans made involved the dark regions visible even without telescopes. Ancient astronomers once believed these enormous patches were seas or oceans. Early European scientists later called them Maria, Latin for seas. Names like Mare Tranquillitatis, the Sea of Tranquility, still survive on lunar maps today. But there was never water there. The Maria are actually enormous plains formed by ancient volcanic eruptions billions of years ago. At some point in the moon's distant past, massive impacts cracked parts of the crust deeply enough for molten lava to flood across the surface. Those lava plains later cooled into darker basaltic rock, creating the giant, shadowy regions visible from Earth. What makes them eerie is their scale. Some lava flows covered areas larger than entire countries. Imagine standing on the moon billions of years ago, while glowing volcanic rivers stretched beyond the horizon beneath a black sky filled with stars that never twinkled. And strangely, most of these Maria exist on the side facing Earth. The far side of the moon looks completely different. For almost all of human history, nobody knew that. Because the moon is tidally locked, it always shows the same hemisphere toward Earth. Every civilization that ever existed before the space age saw only one face of the moon. The hidden side remained completely unknown until spacecraft finally photographed it in the 20th century. When those images returned, scientists were surprised. The far side was rougher, brighter, and packed with far more craters. The enormous dark Maria covering the near side were mostly absent. Even today, researchers still debate exactly why the two hemispheres developed so differently. One possibility involves uneven crust thickness. Another suggests ancient heat distribution inside the moon may have caused volcanic activity to concentrate primarily on the Earth-facing side. But despite decades of research, parts of the mystery remain unresolved. The moon often appears simple from a distance. Up close, it becomes deeply uneven and strangely asymmetrical. Some lunar craters are so large they almost feel artificial in scale. The South Pole Aitken Basin on the far side stretches roughly 1,600 miles across, making it one of the largest impact structures in the solar system. The collision that created it may have excavated material from deep inside the moon itself. Scientists continue studying this region because it could reveal information about the moon's hidden interior. And hidden is the correct word. The moon's surface only tells part of the story. Beneath the dust and craters may exist gigantic underground tunnels formed long ago by flowing lava. These structures, known as lava tubes, formed when molten rock hardened on the outside, while liquid lava continued moving underneath. Once the lava drained away, hollow tunnels remained behind. On Earth, lava tubes already exist naturally, but on the moon, conditions may have allowed them to become enormous. Some scientists believe certain lunar lava tubes could be wide enough to fit entire cities inside. That possibility has attracted serious interest because these underground spaces might someday protect human explorers from radiation, micrometeorites, and extreme temperatures on the surface. And those temperatures are brutal. Without a thick atmosphere to distribute heat, the moon experiences enormous temperature swings. In direct sunlight, surface temperatures can exceed 250 degrees Fahrenheit. In darkness, they can plunge below -200 degrees. Entire regions near the poles may remain trapped in permanent shadow for billions of years because sunlight never reaches the bottoms of certain deep craters. These frozen craters have become one of the moon's most fascinating mysteries. Scientists believe some may contain ancient ice deposits preserved in darkness since the earliest history of the solar system. Water molecules delivered by comets or solar wind interactions could have accumulated slowly over unimaginable stretches of time. If enough ice exists there, future lunar missions may eventually use it for drinking water, oxygen production, or rocket fuel. In a strange way, some of the coldest places in the solar system may hide one of the most important resources for future human survival. But the moon remains dangerous in ways early missions barely anticipated. One of the biggest surprises during the Apollo program involved the lunar dust itself. At first glance, it looks soft, almost like gray powder. But unlike Earth dust, lunar particles were never rounded by wind or water erosion. Under microscopes, the grains appear jagged and razor-sharp. Apollo astronauts reported that the dust clung aggressively to spacesuits, equipment, and skin. It scratched surfaces, damaged seals, irritated eyes, and even produced strange smells inside spacecraft cabins. Some astronauts compared the odor to burned gunpowder. Others described the dust as one of the most difficult engineering problems for future moon exploration. Tiny particles floated into equipment constantly because lunar gravity is weaker than Earth's. Once disturbed, the dust behaved almost unnaturally compared to ordinary dirt on Earth. And there may still be behaviors scientists do not fully understand. For centuries, observers occasionally reported strange flashes, glowing patches, or temporary lights appearing on the moon's surface. These events became known as transient lunar phenomena, or TLPs. Some sightings involved brief reddish glows. Others described hazy regions or sudden brightening near specific craters. The problem is that many observations were inconsistent and difficult to verify scientifically. Some researchers suspect certain reports may have resulted from observational errors, atmospheric distortion, or psychological expectation. Others believe at least some events could involve real lunar activity, such as gas releases, electrostatic dust movement, or small impacts striking the surface. Even now, there is no universal agreement explaining every report. That uncertainty helped fuel decades of speculation far beyond mainstream science. Over the years, people have claimed to see artificial structures, towers, geometric patterns, and even evidence of alien construction on the moon. Most scientists reject such interpretations because lighting conditions, shadows, and low-resolution imagery can easily create misleading shapes. Human brains naturally search for familiar patterns, especially faces and symmetrical forms. Still, the persistence of these claims reveals something psychologically fascinating. The moon feels close enough to study, yet distant enough to remain mysterious. And nowhere does that feeling become stronger than on the far side. The phrase, "dark side of the moon," is technically misleading because all sides receive sunlight. But emotionally, the phrase endured because the far side remained hidden for so long. Even today, humans have explored only a tiny fraction of the lunar surface directly. Huge regions remain untouched by human footsteps. Entire crater systems exist where no astronaut has ever stood. Some scientists believe future discoveries beneath the surface may dramatically reshape our understanding of lunar history. Moonquakes, for example, revealed that the moon is not entirely geologically dead. Seismic instruments left behind during Apollo missions detected vibrations caused by impacts, tidal stresses, and internal activity. Some quakes lasted surprisingly long compared to earthquakes on Earth, because the dry lunar crust transmits vibrations differently. The moon still moves, still cracks, still responds to gravitational forces. And perhaps the strangest thing about the moon's surface is how isolated it truly feels. There is no wind, no weather, no sound moving naturally across the landscape. Footprints left by Apollo astronauts may remain visible for millions of years unless destroyed by future impacts. Rover tracks still cut across the dust exactly where humans left them decades ago. Time behaves differently there. The moon preserves moments almost unnaturally well. A world where history does not easily disappear. Perhaps that is why the moon continues pulling at human curiosity, generation after generation. It is familiar enough to dominate our skies, yet alien enough to feel almost unreal. A place where ancient volcanic floods froze beneath eternal darkness, where giant craters preserve the scars of the early solar system, where frozen water may hide inside shadows untouched for billions of years, where underground tunnels larger than cities could still wait beneath layers of silent dust. And despite centuries of observation, humans still know surprisingly little about large portions of it. The moon may be the closest world to Earth, but in many ways, it remains one of the strangest places humans have ever seen. For almost all of human history, there was one side of the moon nobody had ever seen. Every ancient civilization looked upward at the same familiar face night after night, the same dark maria, the same pale craters, the same silver patterns humans turned into gods, rabbits, spirits, oceans, and myths. Empires rose beneath that view for thousands of years, believing they knew the moon. But hidden beyond the curved horizon was another world entirely. One permanently turned away from Earth, silent and invisible across the whole span of recorded history. The far side of the moon remained unknown longer than nearly every place on Earth. No human eyes saw it directly until the space age. And when humanity finally did see it, the images felt strangely unsettling. The phrase "dark side of the moon" is technically inaccurate. Sunlight reaches every part of the lunar surface over time. But emotionally, the name endured because the hidden hemisphere carried something deeply mysterious. It represented an entire landscape humans knew existed, but could never observe from Earth, no matter how powerful their telescopes became. The reason is locked into gravity itself. The moon rotates at exactly the same speed that it orbits Earth, a phenomenon known as tidal locking. As a result, one hemisphere always faces Earth, while the other remains permanently hidden from direct view. That synchronization likely developed gradually over immense stretches of time, as gravitational forces slowed the moon's rotation billions of years ago. What is strange is how complete the illusion feels from Earth. Even though the moon turns through space, ancient humans experienced it as motionless. One side became familiar, the other became unknowable. And for centuries, people imagined what might exist there. Some early writers speculated about hidden oceans. Others imagined alien civilizations or eternal darkness. A few philosophers even wondered whether the far side might contain landscapes completely different from the visible moon. Without evidence, the hidden hemisphere became a blank canvas for human imagination. Then, in 1959, the Soviet spacecraft Luna 3 changed everything. The spacecraft flew around the moon, carrying primitive cameras, and transmitted the first blurry photographs of the far side back to Earth. The images were rough, distorted, and incomplete by modern standards, but they revealed something astonishing almost immediately. The hidden side looked nothing like the moon people knew. The near side, visible from Earth, contains enormous dark maria created by ancient volcanic floods billions of years ago. But the far side appeared brighter, rougher, and far more heavily cratered. Instead of broad, dark plains, it was dominated by highlands and overlapping impact scars stretching endlessly across the surface. Scientists were surprised because they had expected greater symmetry. Even now, researchers continue debating exactly why the two hemispheres evolved so differently. One leading explanation suggests the crust on the far side became thicker early in lunar history, making it harder for lava to break through and flood the surface the way it did on the near side. Another possibility involves uneven heat distribution inside the moon long ago. But despite decades of orbital mapping and analysis, parts of the mystery remain unresolved. The moon's two faces still feel strangely mismatched. And the farther scientists explored the hidden hemisphere, the stranger it became. One of the most dramatic features on the far side is the South Pole Aitken Basin, a colossal impact structure stretching roughly 1,600 miles across. It is so enormous that it barely feels like a crater at all. The impact that created it may have punched deep into the moon's crust, excavating material from far beneath the surface. Some researchers believe this basin could preserve clues about the moon's ancient interior, including information from the earliest stages of lunar formation. In a sense, the far side may contain parts of the moon's history hidden nowhere else. And yet, humans have barely explored it directly. No Apollo astronaut ever traveled there. Every human landing occurred on the near side, partly because communication with Earth was easier. Radio signals cannot travel directly through the moon itself, meaning astronauts on the far side would disappear completely from direct contact unless relay satellites orbited overhead. That isolation changes the emotional feeling of the place dramatically. If you stood on the far side of the moon, Earth itself would never rise into the sky above you. There would be no glowing blue planet hanging overhead, no visible sign of humanity. Only black space, silent mountains, and ancient craters stretching beyond the horizon. Some scientists have described the far side as one of the most isolated environments accessible to humans anywhere in the solar system. And strangely, that isolation may make it scientifically priceless. Earth constantly floods nearby space with radio noise. Television broadcasts, military transmissions, satellites, radar systems, cell towers, and electrical systems create a storm of electromagnetic interference surrounding the planet. But the far side of the moon remains naturally shielded from much of that noise because the moon itself blocks the signals. In other words, the hidden hemisphere may be the quietest large-scale radio environment near Earth. That possibility has fascinated astronomers for years. Some researchers hope future observatories built on the far side could study extremely faint cosmic signals impossible to detect clearly from Earth. Ancient radio emissions from the early universe may survive there more cleanly than anywhere else nearby. The moon's hidden side might someday help humanity study the birth of the cosmos itself. And yet, despite its scientific importance, huge portions remain poorly explored compared to Earth. Certain craters near the lunar poles have become especially interesting because parts of them never receive sunlight at all. Deep inside these permanently shadowed regions, temperatures remain so cold that water ice may have survived for billions of years. Some measurements from orbiting spacecraft strongly suggest frozen deposits exist within these dark craters. If enough ice is present, the implications become enormous. Water means drinking supplies, oxygen, rocket fuel, long-term survival. For future lunar settlements, these frozen shadows may become some of the most valuable places on the moon, but reaching them will not be easy. Many polar craters combine permanent darkness with brutal terrain and extreme cold. Some areas may never experience direct sunlight at any point during the lunar year. Temperatures can plunge below -400 degrees Fahrenheit in certain regions, making them colder than Pluto in some conditions. The far side contains places where sunlight may not have touched the surface for billions of years. That idea almost sounds supernatural. A landscape trapped in darkness longer than complex life has existed on Earth. And because humans know so little about these regions directly, speculation naturally followed. Over the decades, the far side became deeply entangled with conspiracy theories, science fiction, and UFO mythology. Some people claimed hidden alien structures existed there. Others suggested governments concealed discoveries made during space missions. Strange shadows, low-resolution photographs, and misunderstood geological formations fueled endless speculation. Scientists generally dismiss such claims because no convincing evidence supports them. Most supposed structures can be explained through lighting angles, image distortion, or ordinary geology viewed under unusual conditions. But the persistence of those theories reveals something psychologically important. The far side still feels hidden. Even in the satellite age, humans remain emotionally unsettled by landscapes they cannot easily see for themselves. And in some ways, the moon encourages that feeling naturally. Its silence feels ancient. Its geography preserves billions of years of impacts. Its hidden hemisphere remained invisible for nearly all of human existence. Even now, there are regions where no human being has ever stood, no rover has crossed, and no machine has explored in detail. The unknown still exists there. That unknown became even more fascinating in 2019 when China's Chang'e 4 mission achieved something no country had done before: a successful landing on the far side of the moon. Because direct communication with Earth was impossible, the mission relied on a relay satellite positioned carefully beyond the lunar horizon. For the first time in history, humans operated a rover directly on the hidden hemisphere. The images returned showed barren landscapes, fractured terrain, gray dust, and cratered horizons extending beneath a perfectly black sky. Nothing moved, nothing changed. The place looked almost frozen outside of time itself. And perhaps that is part of what makes the far side so compelling. It reminds humans how little of the universe truly belongs to them. Even Earth's nearest celestial neighbor still contains vast, unexplored terrain and unanswered questions. The moon appears familiar because humans see it constantly, but familiarity can be deceptive. Entire regions remain untouched. Geological puzzles remain unresolved. Frozen craters preserve ancient material older than most landscapes on Earth. Hidden basins may contain records from the violent birth of the solar system itself. The far side is not literally darker than the near side, but psychologically, it still feels like the moon's hidden memory, a place humanity sensed for thousands of years without ever seeing. And even now, after satellites, landers, and decades of research, the hidden hemisphere continues holding on to part of its mystery, silent beyond the horizon, facing permanently away from the world that spent so long imagining what might be there. For thousands of years, human beings looked at the moon and imagined reaching it someday. Ancient civilizations turned it into myths. Philosophers debated what it might be made of. Writers imagined impossible journeys across the sky, long before engines or electricity existed. But for most of human history, the moon belonged to the same category as the stars: visible, beautiful, and completely unreachable. Then, within a single generation, humans went from building primitive airplanes to walking on another world. And strangely, the race that carried people to the moon was not driven entirely by curiosity. It began with fear. In October of 1957, the Soviet Union launched a polished metal sphere called Sputnik 1 into orbit around Earth. The satellite itself was simple, roughly the size of a beach ball, but its impact on the world was enormous. As Sputnik passed overhead, emitting steady radio beeps from space, millions of Americans suddenly realized something unsettling. The Soviet Union had reached space first. That moment changed the Cold War permanently. Until then, space had largely belonged to science fiction and theoretical physics. Suddenly, it became political territory. Military leaders worried that rockets capable of launching satellites could also launch nuclear weapons across continents. Newspapers described a growing missile gap. The sky itself began feeling contested. And somewhere beyond all that fear was the moon. At first, nobody truly knew how difficult reaching it would be. Engineers understood orbital mechanics mathematically, but real spaceflight remained dangerously experimental. Rockets exploded constantly during testing. Guidance systems failed. Tiny engineering mistakes could destroy entire missions within seconds. The early years of the space race often looked less like confident exploration and more like controlled chaos. Both the United States and Soviet Union pushed forward aggressively anyway. The Soviets achieved several stunning firsts early on. They launched the first satellite, sent the first animal into orbit, and eventually carried the first human into space. In 1961, Yuri Gagarin orbited Earth aboard Vostok 1 and returned safely, becoming an international symbol of the new space age almost overnight. For the United States, the pressure intensified. Just weeks after Gagarin's flight, President John F. Kennedy delivered one of the most ambitious political goals in modern history: landing a man on the moon and returning him safely to Earth before the decade ended. At the time, the statement bordered on unbelievable. The United States had barely begun sending humans into space at all. Many of the required technologies did not fully exist yet. Computers remained primitive. Spacecraft reliability was uncertain. Even surviving launch and re-entry safely was still a major challenge. But the moon had become more than a destination. It became proof. Proof of technological power. Proof of political strength. Proof that humans could master environments once considered impossible. And the deeper engineers pushed into the problem, the more dangerous it appeared. One of the strangest aspects of the Apollo program is how fragile much of the technology seems by modern standards. The computers guiding astronauts to the moon possessed less processing power than many everyday electronic devices today. Navigation calculations required extraordinary precision despite limited computing capability. Thousands of engineers, mathematicians, and technicians worked together to solve problems nobody had encountered before because there was no previous blueprint for landing humans on another world. Every mission involved uncertainty and occasionally tragedy. In January 1967, astronauts Gus Grissom, Ed White, and Roger Chaffee entered the Apollo 1 command module during a launch rehearsal on the ground. A fire ignited inside the capsule. Because the cabin contained pure oxygen and the hatch design opened inward, the astronauts had almost no chance to escape. All 3 men died within minutes. The disaster shocked NASA deeply. Investigators uncovered wiring problems, flammable materials, and engineering flaws that forced major redesigns throughout the Apollo program. For a time, some people questioned whether reaching the moon was worth the risk at all. But the program continued. And perhaps that persistence reveals something unusual about the moon itself. Throughout history, humans repeatedly accepted enormous danger simply for the chance to reach places they did not fully understand. Astronaut training became brutally intense. Crews spent countless hours inside simulators rehearsing emergencies repeatedly, because even small mistakes in space could become fatal instantly. They trained underwater to simulate weightlessness. They practiced survival scenarios in deserts and oceans. Engineers studied how isolation, confinement, and stress affected human performance under extreme conditions. And still, nobody could fully predict what walking on the moon would feel like. As Apollo missions progressed, NASA slowly pushed farther from Earth. Astronauts orbited the moon for the first time during Apollo 8 in 1968. That mission alone transformed human perspective forever. For the first time, humans traveled beyond Earth's gravitational neighborhood and watched the planet rise above the lunar horizon. The famous Earthrise photograph taken during Apollo 8 became one of the most influential images in modern history. A small blue world floating alone in darkness. Fragile, silent, finite. Many astronauts later described that view as psychologically overwhelming. Looking back at Earth from lunar distance changed how they thought about politics, borders, and civilization itself. From far enough away, the conflicts consuming humanity suddenly appeared strangely temporary. And yet, the most dangerous part still remained ahead. Landing on the moon was far more difficult than orbiting it. By July 1969, Apollo 11 carried Neil Armstrong, Buzz Aldrin, and Michael Collins toward the moon, while hundreds of millions of people followed the mission across television and radio broadcasts worldwide. Entire cities stayed awake through the night, listening to updates. The moon, once associated mostly with myths and distant dreams, was about to receive human footsteps. But during the final descent, things started going wrong. Computer alarms suddenly filled the lunar module cockpit. Guidance systems became overloaded. Fuel reserves dropped lower and lower, while Armstrong searched manually for a safe landing area because the automatic targeting system was carrying them toward dangerous terrain filled with boulders. For several terrifying moments, mission controllers on Earth were unsure whether the landing would fail completely. Some estimates suggest the lunar module touched down with less than half a minute of usable fuel remaining. Then came the message: "The Eagle has landed." And suddenly, after thousands of years of wandering, humans had reached the moon. What happened next became one of the most replayed moments in history. Neil Armstrong descended the ladder slowly and stepped onto the lunar surface, while television cameras transmitted ghostly black and white images back to Earth. The footage looked fragile and unreal, almost dreamlike. A human being moved across another world beneath a black sky untouched by atmosphere. But one detail many astronauts later emphasized was the silence. The moon itself made no sound. No wind moved across the landscape. No insects. No distant water. Outside the spacesuits, the environment remained completely still, except for vibrations transmitted mechanically through equipment and footsteps. Several astronauts described the lunar surface as emotionally strange, partly because of that silence. The landscape felt ancient beyond comprehension. And yet, despite the success of Apollo 11, the danger never disappeared. Every mission carried life-threatening risks. Tiny mechanical failures could have stranded astronauts permanently. Radiation exposure remained a concern. Lunar dust damaged equipment. Re-entry through Earth's atmosphere involved tremendous heat and precision timing. During Apollo 13, an oxygen tank explosion nearly killed the crew entirely and forced NASA into one of the most famous rescue improvisations in modern history. The moon race often balanced between triumph and disaster. And then, surprisingly quickly, it ended. After Apollo 17 in 1972, humans stopped traveling to the moon entirely. No astronaut has walked on the lunar surface since. Political priorities shifted. Public excitement gradually faded. The enormous costs became harder to justify during economic and geopolitical changes back on Earth. In some ways, that abrupt ending feels almost surreal now. Human beings reached another world, then simply stopped returning. Conspiracy theories later emerged, partly because of how strange that timeline feels emotionally. Some people questioned why humanity never established permanent lunar bases or continued regular missions after such a monumental achievement. Others falsely claimed the moon landings themselves had been staged, despite overwhelming physical evidence proving otherwise, including lunar rock samples, retroreflectors still functioning on the moon today, telemetry data, independent tracking by other nations, and extensive mission documentation. But perhaps the real mystery is not whether humans went. It is why reaching the moon changed human imagination so permanently. For the first time, ancient myths collided directly with physical reality. The moon stopped being only a symbol and became a place, a real landscape humans could walk across, touch, and leave footprints upon. And yet, strangely, that reality did not destroy the moon's mystery. If anything, it deepened it. Because once astronauts finally stood there, looking back at Earth, hanging silently above the horizon, the universe suddenly felt both smaller and infinitely larger at the same time. The moon was no longer unreachable, which meant perhaps other worlds were not unreachable either. When astronauts finally reached the moon, scientists expected technical challenges. They expected dangerous landings, equipment failures, radiation risks, and mechanical problems. What they understood far less clearly was what the experience itself would do to the human mind. Because standing on the moon turned out to feel stranger than many astronauts could fully explain. From Earth, space often looks beautiful and peaceful in photographs. The moon appears silent, clean, almost dreamlike. But astronauts repeatedly described lunar missions using words that sounded unexpectedly emotional. Lonely, unsettling, overwhelming, disorienting. Some struggled to describe the feeling at all, because nothing in normal human experience truly compares to leaving Earth behind and walking across another world beneath a sky with no atmosphere, no sound, and no sign of life. The moon did not feel like a destination humans were meant to visit. It felt ancient. The first shock for many astronauts was the silence itself. On Earth, silence is rarely complete. Even deep in remote wilderness, there is usually wind moving through trees, distant water, insects, birds, or subtle vibrations in the environment. The moon has none of that. Outside a spacesuit, there is no air to carry sound naturally across the landscape. A hammer dropped onto lunar dust makes no audible noise, unless vibrations travel through the astronaut's body or equipment. Several Apollo astronauts later described the silence as psychologically unsettling because it felt unnatural on a deeply instinctive level. The moon did not sound dead, it sounded absent. And visually, it behaved strangely too. The lunar sky remained completely black even during daytime because there is no atmosphere to scatter sunlight. Astronauts could stand on brightly illuminated ground while staring upward into a darkness filled with sharp, unmoving stars. But often, the stars themselves became difficult to see because sunlight reflecting off the lunar surface and spacesuits overwhelmed human vision. The result created a bizarre contradiction. The moon was flooded with sunlight, yet space above it looked like an endless void. Many astronauts said depth perception became difficult there as well. Without atmosphere, distant mountains appeared unnaturally sharp. Shadows turned completely black because there was no air to soften light. Objects looked closer or farther away than expected. Craters blended strangely into the terrain depending on the sun's angle. Even walking became psychologically awkward. The moon's gravity is only about 1/6 of Earth's, which changed movement completely. Astronauts bounced, hopped, and drifted across the surface in ways that looked almost playful from Earth. But inside the suits, the experience was exhausting. Every movement required careful balance because the bulky equipment restricted motion constantly. Falling could damage life support systems. Fine dust coated boots and tools relentlessly. And the dust itself became one of the strangest surprises of all. Apollo astronauts repeatedly commented on the smell of lunar dust after returning inside the spacecraft. Because there is no atmosphere on the moon, the dust itself technically carries no smell outdoors. But once particles entered the cabin and mixed with oxygen, astronauts noticed an odor many compared to burned gunpowder or spent fireworks. Nobody had expected the moon to smell like anything. The dust also behaved almost aggressively. tiny, jagged particles clung to suits, floated through the cabin, irritated throats and eyes, and worked their way into equipment seals. Some astronauts worried future long-duration missions might face serious health risks from inhaling lunar dust repeatedly. What looked soft and harmless from Earth turned out to be abrasive and invasive up close. And then there was the isolation. During missions to the Moon, astronauts traveled farther from Earth than any humans in history. Once spacecraft moved behind the lunar horizon, radio communication disappeared completely for a period of time. No voices from Earth, no transmissions, no contact at all, just silence. Several astronauts later described those moments behind the Moon as emotionally powerful because Earth itself vanished entirely from view. For a brief period, they became the most isolated human beings alive. No civilization visible, no oceans, no lights. Only black space surrounding a small spacecraft moving above endless craters. Perhaps the most psychologically significant experience reported by astronauts became known later as the overview effect. Many space travelers described a profound mental shift after seeing Earth from space directly. National borders disappeared visually. Political conflicts felt strangely small. Earth appeared fragile, isolated, and intensely alive against the darkness surrounding it. Apollo astronaut Edgar Mitchell later described an overwhelming sense of interconnectedness while returning from the Moon. Others spoke about the emotional difficulty of explaining the experience afterward because language itself seemed inadequate. The Moon changed how they thought about Earth more than how they thought about the Moon. And strangely, some astronauts returned quieter than before. A few became deeply reflective. Others experienced periods of emotional confusion after returning to ordinary life. Historians and psychologists still debate exactly why these reactions occurred. Part of it may have involved stress, isolation, danger, media pressure, or post-mission exhaustion. But some researchers believe confronting the scale of space directly can alter human perspective in ways difficult to process psychologically. Imagine standing on the Moon and realizing every person you have ever known, every war in history, every city, every language, every memory of human civilization exists on a glowing sphere hanging silently above the horizon. The experience may have felt spiritually overwhelming even for astronauts trained scientifically. And not every strange report involved emotions alone. Over the years, stories emerged about unusual observations during space missions. Some astronauts described seeing unexplained flashes of light while traveling beyond Earth's protective atmosphere. Scientists later suggested many of these flashes were likely caused by cosmic rays striking the retina directly, energetic particles interacting with human vision in deep space. But for astronauts floating in darkness, the effect could feel eerie. Lights appearing inside closed eyes, silent flashes crossing vision where no atmosphere existed. The human nervous system itself reacting visibly to outer space. Other stories became more controversial. A few astronauts mentioned hearing unusual sounds during radio communications or observing objects they struggled to identify immediately. Most such incidents eventually received ordinary explanations involving equipment interference, lighting conditions, orbital debris, or misunderstood visual perspectives. Yet the isolated environment of space naturally amplified uncertainty. Far from Earth, even ordinary phenomena could feel deeply strange. Sleep itself also became difficult. Inside spacecraft, astronauts experienced constant mechanical noise from ventilation systems and electronics. Weightlessness altered normal body sensations. Sunrises occurred rapidly during orbit. Stress hormones remained elevated. Some astronauts reported vivid dreams during missions, while others struggled with exhaustion despite intense fatigue. Human biology evolved on Earth. Space constantly reminded astronauts of that fact. Even simple tasks became psychologically demanding under lunar conditions. Time moved differently without normal environmental cues. The moon lacked weather, movement, vegetation, or changing sounds. The landscape remained visually frozen hour after hour beneath harsh sunlight and black shadows. Several astronauts described the surface as eerily timeless. Not empty exactly, more like abandoned. And perhaps the strangest emotional contradiction of all was how beautiful and hostile the moon felt simultaneously. Astronauts often describe moments of awe while watching Earth rise above the horizon or seeing sunlight stretch across crater rims. Yet at the same time, they knew the environment could kill them almost instantly if equipment failed. One torn suit, one damaged oxygen line, one critical malfunction, and survival would become impossible within minutes. The moon allowed no mistakes. That constant awareness shaped every experience there. Even the famous Apollo footage, showing astronauts hopping across the surface, sometimes hides how dangerous the missions truly were. Beneath the calm radio conversations and slow movements was enormous tension. Every EVA, every excursion outside the spacecraft, balanced directly between exploration and catastrophe. And still, despite all the danger, many astronauts later expressed a powerful desire to return. Something about the moon stayed with them psychologically. Maybe it was the silence. Maybe it was seeing Earth from so far away. Or maybe humans are simply not emotionally prepared for landscapes that old and empty. Because on the moon, astronauts encountered something rare in human history, a place untouched by life entirely. No trees, no oceans, no smell of rain, no evidence that biology had ever existed there at all. Just stone, dust, radiation, darkness, and the preserved scars of billions of years. A world where nothing lives. And yet, humans walked there anyway. Perhaps that is what makes the astronaut experience so fascinating. The missions were technological achievements, but they were also psychological experiments humans barely understood at the time. They revealed how the human mind reacts when removed completely from Earth's familiar systems. Gravity, weather, sound, atmosphere, distance, and even the normal rhythm of day and night. The moon did not merely test machines, it tested perception itself. And after returning home, many astronauts carried the feeling with them permanently. The memory of standing inside absolute silence beneath a black sky, looking upward at a distant blue Earth, glowing alone in the darkness, while realizing how thin the boundary between civilization and emptiness truly is. Even after centuries of observation, lunar maps, orbiting satellites, and human landings, the moon still hides enormous amounts of itself from human understanding. That may sound surprising at first. The moon is Earth's closest celestial neighbor. Humans have walked on it, driven across it, drilled into it, and brought pieces of it back home. And yet, the deeper scientists investigate the lunar surface, the more the moon begins to feel less like a completely understood world and more like a place filled with unanswered questions, quietly waiting beneath layers of dust and stone. Part of that mystery comes from how deceptive the moon appears from Earth. From a distance, it looks dead, static, predictable. But hidden beneath the surface are signs of ancient volcanic activity, buried ice, deep fractures, seismic movement, and geological processes researchers still debate today. The moon is often described as geologically inactive, yet evidence suggests its history may have been far more complicated than scientists once believed. One of the biggest surprises involved water. For decades, many researchers assumed the moon was almost completely dry. The Apollo missions found no lakes, rivers, weather systems, or obvious moisture on the surface. Under direct sunlight, exposed water would quickly evaporate into space because the moon lacks a thick atmosphere. The lunar environment seemed too hostile for ice to survive. Then, scientists started looking into the shadows. Near the lunar poles, certain craters sit at angles where sunlight almost never reaches their interiors. Some regions may have remained in darkness for billions of years. Temperatures inside these permanently shadowed craters can fall below -400 degrees Fahrenheit, creating some of the coldest known environments in the solar system. And inside that darkness, spacecraft began detecting signs of frozen water. At first, the evidence remained uncertain. Different missions produced conflicting interpretations. Some signals suggested hydrogen deposits. Others hinted at ice mixed into the soil. Over time, however, multiple observations strengthened the case that significant amounts of frozen water may exist in polar regions. That discovery changed how scientists thought about the moon completely. Water means survival. It can be turned into drinking supplies, breathable oxygen, and even rocket fuel. Suddenly, the moon stopped looking like a temporary destination and started looking potentially useful for long-term human presence. Entire future base concepts began forming around these frozen polar regions because access to water could reduce the need to transport enormous resources from Earth. But those same craters remain incredibly difficult to explore. Many exist in near total darkness, with dangerous terrain and brutal temperatures. Some scientists compare them to natural deep freeze vaults, preserving material from the early solar system itself. Ancient water molecules delivered by comets billions of years ago may still rest there untouched. In a strange sense, parts of the moon may contain frozen history older than most landscapes on Earth. And hidden beneath the surface may be something even more valuable: gigantic lava tubes. Billions of years ago, the moon was volcanically active. Lava flowed across enormous regions, forming the maria visible from Earth today. As molten rock moved beneath cooling crust, underground channels formed naturally. Once the lava drained away, hollow tunnels remained behind. On Earth, lava tubes already exist in volcanic regions like Hawaii and Iceland. But lunar gravity changes everything. Because the moon's gravity is weaker, some researchers believe lunar lava tubes could become extraordinarily large, potentially wide enough to contain entire city blocks or even larger structures. Certain pits photographed from orbit appear to open directly into massive underground cavities. Scientists have become fascinated by these hidden spaces because they may offer natural shelter from one of the moon's greatest dangers: radiation. Unlike Earth, the moon lacks a global magnetic field and thick atmosphere to protect the surface from cosmic radiation and solar storms. Long-term exposure could seriously damage human health. But underground lava tubes might provide natural shielding strong enough for future habitats. The moon may already contain ready-made shelters beneath its surface, and humans have barely explored them. Then there are the moonquakes. For many years, people imagined the moon as completely inactive, a cold, dead object frozen permanently in time. But seismic instruments left behind during Apollo missions detected vibrations moving through the lunar interior. Some moonquakes were triggered by meteor impacts. Others appeared linked to tidal forces caused by Earth's gravity pulling on the moon itself. What surprised scientists was how long some of these vibrations lasted. On Earth, water and complex geology dampen seismic waves relatively quickly. But the moon behaves differently. Certain moonquakes continued reverberating for surprisingly extended periods, almost as though the entire lunar interior rang like a bell. That phrase became famous among scientists for a reason. The moon did not merely shake, it resonated. And even today, researchers still debate details about the moon's internal structure. Evidence suggests the moon likely possesses a core, but questions remain regarding its exact composition and size. Some models indicate portions may still remain partially molten deep below the crust. The deeper humans look, the less completely frozen the moon appears. Another strange discovery involves magnetism. Today, the moon lacks a strong global magnetic field like Earth's. Yet, some lunar rocks contain magnetic signatures suggesting that billions of years ago, the moon may once have possessed a much stronger magnetic environment. Scientists continue debating how such a field formed and why it disappeared. One possibility suggests the moon's core generated magnetism early in its history, before cooling gradually over time. Another idea proposes large asteroid impacts may have temporarily amplified magnetic effects in certain regions. Whatever the explanation, it reveals something unsettling. The moon humans see today may be only the final quiet stage of a far more active and violent world. And then there are the unusual materials hidden in the lunar soil itself. Certain regions contain surprisingly high concentrations of helium-3, a rare isotope extremely scarce on Earth. Some researchers have suggested helium-3 could someday become valuable for future fusion energy technologies, if practical fusion reactors are ever developed successfully. At the moment, that remains speculative. Fusion power itself still faces enormous scientific and engineering challenges. But the idea that the moon may hold resources capable of reshaping future civilizations has attracted growing attention from governments and private companies alike. The modern moon race may not be driven by prestige alone anymore. It may eventually involve energy, infrastructure, survival, and control over extraterrestrial resources. And yet, despite all these discoveries, huge portions of the moon remain almost completely unexplored directly. Only 12 humans have ever walked there. No one has visited since 1972. Entire crater systems remain untouched. Vast underground spaces may still wait beneath the surface undiscovered. Polar shadows preserve ancient material humans have never sampled directly. Even basic questions about the moon's formation and geological evolution continue generating debate among scientists. In some ways, humanity still knows the moon mostly from orbit. That uncertainty leaves room for speculation, and the moon has attracted speculation for centuries. Over the years, people have pointed to unusual photographs, strained reflections, geometric-looking shadows, and unexplained surface features as evidence of hidden structures or non-human activity. Scientists generally reject these interpretations because lighting conditions, low image resolution, and the human tendency to recognize patterns can easily create misleading impressions. The brain wants meaning, especially in landscapes that already feel mysterious. But the persistence of those theories reveals something deeper about the moon itself. Unlike Mars or distant planets, the moon feels emotionally close enough to imagine secrets hiding there. Humans can look up and see it directly almost every night. It dominates Earth's skies while still remaining physically unreachable for most of human history. Familiarity creates intimacy. Distance preserves mystery. And perhaps nowhere does that balance feel stranger than in the permanently shadowed craters near the poles. Some of these regions have remained untouched by sunlight for unimaginable stretches of time. If ancient ice survives there, then molecules from the early solar system may still rest beneath layers of darkness older than human civilization, older than mammals, older even than dinosaurs. Tiny frozen records from the birth of planets, waiting silently inside craters no sunlight has ever warmed. That image changes the emotional feeling of the moon entirely. It stops being just a gray object in the sky and starts feeling more like an archive, a preserved memory vault from the earliest history of the solar system. While Earth constantly erased its own past through erosion, weather, oceans, and tectonic activity, the moon quietly kept much of its history intact. The surface humans see tonight may contain clues about ancient impacts, vanished magnetic fields, volcanic oceans, buried ice, underground caverns, and perhaps resources future civilizations may someday depend upon. And the strangest part is how much remains unknown despite the moon being so close. Human beings have crossed oceans, mapped continents, explored jungles, and sent robotic probes far beyond Pluto. Yet only a tiny number of people have ever stood on the moon itself. Most of its hidden places remain untouched beneath billions of years of dust and silence. A nearby world still keeping secrets just beyond Earth's sky. Tonight, the moon probably feels permanent. It rises above cities, oceans, forests, deserts, and mountains, exactly as it has for every human civilization in history. Ancient people built myths around it. Sailors navigated beneath it. Astronauts walked across it. Entire calendars still follow its cycles. The moon feels so stable in the night sky that most people never seriously imagine Earth without it. But what if it disappeared? Not exploded dramatically, not crashing into Earth in some apocalyptic firestorm, just gone. One moment, the moon hangs above the planet as usual. The next moment, Earth faces the sky alone. At first, the world might appear strangely normal. Oceans would still move. The sun would still rise. Cities would continue glowing beneath artificial light. Many people might not immediately notice the difference during daylight hours. But the planet itself would already be changing. The most immediate effect would involve the tides. The moon's gravity currently drives the strongest tidal forces on Earth. The sun also influences tides, but much more weakly. Without the moon, ocean tides would not disappear completely, yet they would shrink dramatically. Coastal environments shaped by powerful lunar cycles would begin transforming almost immediately. Some tidal wetlands would dry differently. Certain coastlines would become calmer. Marine ecosystems adapted to rhythmic flooding and retreat could begin destabilizing. At first glance, weaker tides might not sound catastrophic, but tides do far more than move water along beaches. They help circulate nutrients through coastal ecosystems, influence temperature mixing in parts of the ocean, and shape the behavior of countless species that evolved around predictable lunar rhythms. Entire biological systems depend on those cycles. Certain coral reefs release reproductive material according to moon phases. Some fish coordinate spawning with tides. Crabs, shellfish, marine worms, and countless coastal organisms evolved inside environmental rhythms controlled partly by lunar gravity. Remove the moon, and many of those ancient patterns begin breaking apart. Not instantly, but steadily. And the effects could spread much farther than coastlines. One of the moon's most important roles is something humans almost never notice directly: stabilizing Earth's axial tilt. Right now, Earth tilts at roughly 23.5 degrees as it orbits the Sun, creating relatively stable seasonal cycles. The moon acts almost like a gravitational anchor, helping limit chaotic shifts in that tilt over long periods of time. Without the moon, Earth would become less stable, not necessarily immediately chaotic, but far less predictable across geological timescales. Some climate models suggest Earth's tilt could eventually swing dramatically without lunar stabilization. In extreme scenarios, parts of the planet might experience severe climate changes as the angle of sunlight shifts unpredictably over millions of years. Deserts could move. Ice sheets could expand or collapse differently. Entire ecosystems might struggle to adapt to rapidly changing environmental patterns. The strange part is that humans may never have evolved under such unstable conditions in the first place. The moon may have quietly protected Earth's long-term habitability for billions of years. And if it vanished now, the loss would unfold gradually enough that people might underestimate the danger at first. The nights themselves would also change dramatically. A full moon provides surprisingly large amounts of natural illumination under dark skies. Before electricity existed, moonlight transformed human behavior. Travel, hunting, fishing, rituals, and navigation often depended on lunar brightness. Even today, many animals rely heavily on moonlight patterns for movement and survival. Without the moon, nighttime would become much darker. In remote regions far from artificial lights, the difference would feel enormous. Forests, deserts, mountains, and oceans would experience deeper darkness during clear nights. Predators that rely on moonlight might struggle. Prey species adapted to lunar visibility cycles could behave differently. Some researchers believe entire nocturnal ecosystems would slowly reorganize. And psychologically, humans would likely feel the absence too. For most of human history, people evolved beneath a sky containing a large, bright object constantly changing shape above them. The moon became embedded in mythology, calendars, religion, language, storytelling, and emotional experience itself. Remove it, and the night sky would feel strangely empty. Even timekeeping might have evolved differently without lunar cycles. The concept of the month emerged directly from the moon's phases. Ancient civilizations tracked time partly through its changing appearance. Lunar calendars shaped agriculture, religious ceremonies, and navigation long before mechanical clocks existed. A moonless Earth might have produced very different civilizations, perhaps even different mythologies entirely. And then there are eclipses. Total solar eclipses happen because the moon appears almost exactly the same size in Earth's sky as the sun, despite being vastly smaller and closer. This near-perfect alignment is one of the strangest coincidences in astronomy. During eclipses, the moon covers the sun so precisely that humans can observe the solar corona glowing around the edges. Without the moon, those eclipses vanish forever. No sudden darkness during daytime. No glowing corona visible from Earth's surface. No ancient terror surrounding eclipses. One of humanity's most haunting natural phenomena would simply cease to exist. But perhaps the strangest long-term effect involves Earth's rotation itself. Right now, the moon's gravitational pull gradually slows Earth's spin through tidal friction. Billions of years ago, Earth rotated much faster. Days were dramatically shorter. The moon slowly absorbed rotational energy over immense stretches of time, lengthening Earth's days gradually. Without the moon, that braking effect disappears. Earth would stop slowing down at the same rate. The length of a day would stabilize differently than it otherwise would have in the distant future. And strangely enough, the moon itself is already leaving Earth slowly. Laser reflectors left behind during Apollo missions revealed that the moon drifts away from Earth by about 3.8 centimeters every year. It is an almost invisible movement across human lifetimes, but over hundreds of millions of years, the distance becomes enormous. In a sense, Earth is already slowly losing the moon. Not completely, not anytime remotely soon, but gradually. And far enough into the future, the relationship between Earth and Moon will look very different from today. That realization changes the emotional feeling of the night sky slightly. The moon appears eternal, but it is not fixed permanently. It belongs to a long gravitational story still unfolding. Some scientists have also explored another unsettling possibility. Could Earth remain habitable without the moon at all? The answer is complicated. Certain models suggest life could still exist. Oceans would remain, atmosphere would remain, seasons would still occur. But the path of evolution might become far more unstable over deep time. Complex ecosystems could face greater environmental stress. Some researchers suspect intelligent life may be less likely to emerge on worlds lacking large, stabilizing moons. If that idea is true, then Earth's moon may not simply be beautiful. It may be unusually important. That possibility becomes even more fascinating when astronomers study distant planets around other stars. Some researchers now consider large moons potentially significant when evaluating whether alien worlds might support stable, long-term environments for life. The moon may have helped turn Earth from a violent young planet into a place where civilizations could eventually exist. And if it vanished, Earth would not suddenly explode into chaos overnight. The transformation would be slower, subtle at first, then increasingly profound. The oceans would behave differently. The climate would drift differently. The nights would darken. Animal behavior would shift. Ancient rhythms embedded in biology itself would begin unraveling quietly. And perhaps most unsettling of all, humanity would lose something psychological that has followed it since prehistoric times. For tens of thousands of years, every human being who ever lived looked upward and saw the same moon, the same silver light crossing ancient rivers, the same phases above deserts and forests, the same glowing object witnessed by emperors, hunters, sailors, children, astronauts, and civilizations now long vanished. The moon connected generations across time in a strangely intimate way. A permanent companion above Earth. Remove it, and something emotional disappears from the human experience itself. Because the moon is not just part of astronomy, it is part of memory, part of history, part of how humans learn to measure time, imagine gods, navigate oceans, tell stories, study the sky, and eventually leave Earth entirely. And perhaps that is the strangest realization of all. The moon feels distant, yet Earth has never truly lived without it. Not once in the entire history of human civilization, which means nobody really knows what a moonless Earth would emotionally feel like, only that it would no longer feel entirely like home. For most of human history, the moon represented distance. People looked upward and imagined reaching it, the same way they imagined immortality, lost civilizations, or the edge of the universe itself. Beautiful ideas, that belonged more to mythology than reality. Then, within only a few decades, human beings crossed the space between Earth and the Moon, walked across its dust, planted instruments into its surface, and returned home again. And after all that effort, humanity stopped going back. For more than 50 years, no human footprints have appeared beside the Apollo tracks left in the lunar soil. The spacecraft are still there. The flags remain standing in some form, though harsh sunlight likely faded their colors long ago. Rover tracks still cut across the dust exactly where astronauts left them, because the Moon has almost no weather to erase history. It is strange to realize that the last human being to walk on the Moon did so in 1972, long before the internet, before smartphones, before modern digital life even existed. And yet now, after decades of silence, the Moon is becoming important again. Not only as a scientific destination, but as a possible beginning. NASA's Artemis program aims to return astronauts to the lunar surface for the first time in generations. Unlike Apollo, which focused primarily on short-term exploration and political symbolism, newer missions are increasingly centered around long-term presence. Scientists and engineers are no longer asking only whether humans can reach the Moon. They are asking whether humans can stay there. That question changes everything. Because surviving on the Moon for extended periods is far more difficult than simply landing briefly and returning home. The Moon remains brutally hostile to human life. There is almost no atmosphere. Temperatures swing between extremes. Micrometeorites move through space at tremendous speeds. Radiation constantly strikes the surface because there is no global magnetic field protecting it like Earth's. And perhaps most dangerously, the Moon contains almost nothing naturally comfortable for human biology. No air, no weather, no oceans, no ecosystems, no living environment waiting to support civilization. Humans would have to build nearly everything artificially. Yet despite those dangers, governments and private companies around the world are preparing seriously for a future on the Moon. Part of that interest comes from geography. Compared to Mars, the Moon is relatively close. Travel times are measured in days rather than months. Communication delays remain short enough for near real-time contact with Earth. Emergency return missions, while still difficult, are at least theoretically possible. The Moon may become humanity's training ground for surviving beyond Earth permanently. And hidden within its shadows may be the key resource that makes that possible: water. In recent years, evidence for frozen water near the lunar poles has transformed future mission planning. Permanently shadowed craters may contain significant ice deposits preserved for billions of years. If astronauts can successfully access and process that ice, it could provide drinking water, breathable oxygen, and hydrogen fuel for rockets. In other words, future moon bases might not need to depend entirely on Earth forever. That possibility changes the emotional meaning of the Moon completely. It stops being merely a destination humans visit temporarily and starts becoming a place where self-sustaining systems might eventually emerge. Some scientists now imagine underground habitats hidden inside ancient lava tubes beneath the lunar surface. These enormous caverns could shield astronauts from radiation, temperature extremes, and micrometeorite impacts far better than exposed structures on the surface. Entire underground settlements may someday exist inside tunnels created by volcanic eruptions billions of years ago. The idea almost sounds ancient and futuristic at the same time. Human beings sheltering inside the moon itself. And once permanent habitats become possible, another question appears almost immediately. What happens to the human body after living there for years? The moon's gravity is only about 1/6 of Earth's. Scientists still do not fully understand how long-term exposure to such low gravity would affect human development. Astronauts aboard space stations already experience muscle loss, bone density reduction, fluid redistribution, and changes in vision during extended missions in microgravity. The moon may be easier on the body than complete weightlessness, but it still represents an environment humans never evolved to inhabit. Children born on the moon, if that ever happens, could grow differently from humans on Earth. Bones, muscles, cardiovascular systems, and even movement patterns might adapt over generations to lower gravity conditions. A person raised entirely on the moon might someday find Earth's gravity painfully overwhelming. That possibility forces humanity into strange territory psychologically. For the first time in history, future generations may not automatically belong to Earth physically in the same way every human before them did. And the farther scientists study long-term lunar survival, the more civilization itself begins entering the conversation. How would cities function there? What would lunar architecture look like? Would people live mostly underground? Could plants grow successfully under artificial environments using lunar resources? Researchers are already experimenting with methods for growing food in lunar-like soil conditions. Others study how local materials could potentially be used to construct buildings through advanced manufacturing techniques such as 3D printing. Transporting everything from Earth forever would be too expensive and impractical. The moon may eventually require its own infrastructure, its own industries, its own rhythms of life. And once humans begin building permanent systems there, the moon stops feeling like exploration entirely. It becomes colonization. That word remains controversial for understandable historical reasons, and many scientists prefer alternatives like settlement or habitation. But the deeper issue remains difficult to ignore. Humanity may eventually transform the moon from a distant natural object into part of human civilization itself. Some people find that exciting. Others find it deeply unsettling. Because the moon has always represented something untouched, ancient, silent, a place beyond ordinary human control. The idea of industrial activity, mining operations, permanent bases, or artificial lights spreading across the lunar surface changes the emotional meaning of the moon in ways humanity has barely begun discussing. And economics may accelerate that transformation faster than many expect. Certain lunar materials have attracted attention for decades, including helium-3, a rare isotope potentially useful for future fusion energy technologies, if practical fusion reactors are ever achieved. Other researchers focus more on water, rare metals, or the moon's strategic value as a launch platform for deeper missions into the solar system. The moon's weak gravity means spacecraft launching from there would require far less energy than launching from Earth. A future civilization expanding toward Mars or beyond might use the moon as a staging ground, a doorway instead of a destination. And perhaps that is the most profound shift happening quietly now. For thousands of years, humans viewed the moon as the final unreachable object in the sky. Today, scientists increasingly view it as the first step toward a much larger future. The beginning of permanent human movement into space. That possibility becomes emotionally strange when imagining how future lunar residents might experience Earth itself. Apollo astronauts looked back at Earth from the moon and described overwhelming feelings of fragility and unity. But future generations, born or raised partly on the moon, might experience Earth differently. To them, Earth may become something distant and mythic, a giant blue world hanging in the sky the way the moon hangs above Earth tonight. Home could eventually become a glowing object in the heavens, not the ground beneath your feet. And perhaps one day, centuries from now, lunar settlements may no longer feel temporary at all. Artificial habitats could expand beneath crater walls or underground caverns. Permanent observatories might operate on the far side, shielded from Earth's radio noise. Mining systems could function autonomously across ancient basalt plains, while spacecraft depart regularly for deeper regions of the solar system. The moon may become humanity's first true world beyond Earth. Yet for all those possibilities, enormous uncertainty remains. Long-term radiation exposure could prove more dangerous than expected. Psychological isolation may challenge permanent lunar communities in ways difficult to predict. Political conflicts over territory and resources could emerge. Engineering failures in such a hostile environment would carry deadly consequences. The moon is still unforgiving, still silent, still ancient. And perhaps that is what makes humanity's future there feel so fascinating. The moon already shaped Earth's tides, stabilized climates, guided civilizations, inspired myths, and transformed science. Now, it may shape the next phase of human history as well. Not because it changed, but because humanity finally did. For the first time since ancient people stared upward, wondering what the moon truly was, humans are beginning to imagine something even stranger. Not visiting the moon, living there. And if that future truly arrives, then one night, somewhere far ahead in time, a child standing beneath a black lunar sky may look upward and see Earth glowing blue above the horizon. Distant, beautiful, and impossibly alive, while wondering what it would feel like to stand on the world their ancestors once called home. Thanks for exploring the mysteries of the moon with me tonight. If you enjoyed this relaxing journey through ancient lunar secrets, don't forget to subscribe to Sleepy Secrets for more calming documentaries to fall asleep to. And before you drift off, leave a comment sharing what city you're watching from tonight. Wishing you a peaceful night, good health, and good luck wherever you are in the world.